Hi, everybody. And now let's take a look at the final exam review, part 3. And this is really the finale. That's the last things for this semester. Okay, so let's take a look at the problem number 15. Okay, so we want to find the domain for the following functions here. So the first functions here, f of x is equal to 2x minus 9. And then the second one's here, it will be f of x is equal to 1 over, this is x squared minus 2x minus 8. Part C here is f of x is equal to, and x cubed plus 2x squared minus 1 over 1 minus x. Okay, so before we do this problem, let's do a brief review about the domains, right? So we said the domain, we have a couple things we are, we care about. We need to take care of those couple things. After we take care of that, then the domain general could be the all real number, but we need to exclude those concerns here. So the first thing here is we call this a denominator. Okay, so we say the denominator cannot be 0, right? So when you try to find the domains here, you need to exclude the x values which make the denominator equal to 0, right? So that's the one concern here. Then the second concern is the value inside square roots. Has to be what? Has to be greater than or equal to 0. So those things, those are the two things we need to be careful. That means you cannot have a negative inside your square roots here, all right? Okay, so now let's take a look here. The first things here we say, the f of x is 2x minus 9. Well, I see a square root, so I need to make sure, that everything inside the square roots, can be what? Need to be greater than 0. So I will say the 2x minus 9 has to be greater than or equal to 0, right? Based on my second rule here. So I add the 9 both sides here. So I will have a 2x greater than 9. Then I divide by 2, divided by 2. So I will have x greater than equal to the 9 over 2 here, right? So this is my domains here. So the way you can write it, the domains here is greater than equal to, right? So you need to bracket. So this is 9 over 2 to where? To the infinities here, right? Okay, so now the next things here. So for this problem here, the part B, f of x is 1 over x squared minus 2x. You see a fraction. When you see a fraction, then you know the denominator cannot be equal to 0. So the first things I need to do is I need to factor this denominator to see what happens here. So this one's here, it will give me x minus 4 and x plus 2, right? So that means the x cannot be equal to 4, neither x cannot be equal to negative 2. These two values will make the denominator become to 0. So I need to exclude them from the, the domain. So the domains here will be what? So it's everything except these two. So the way you can write it is will be the negative infinity 2, -2, right? So you need to use parentheses because the -2 cannot be. Then you union -2 to 4, right? Then you union 4 to infinities, right? So that is the way. It's like you exclude 4 and the -2s here. All right. Now the last one's here. The last one, if you take a look at this part, this is just a polynomial, x cubed plus 2x squared. Does not have square roots, does not have a fraction. So this part is okay. Now the only part we have trouble is this part, right? So this part does have a fractions here. So as long as you see a fractions, then I know I need to follow the rule. That means the denominator cannot be equal to 0. That means the x what cannot be equal to 1, right? So x can be anything else except 1s here. So that's why the way you can write your domains here, you can say except 1. So it will be the negative infinity to 1 union 1 to the positive infinity, right? That's how do we define the domains here. So make sure you remember these two rules. If you see a fraction, denominator cannot be 0. If you see a square root, everything inside the square root has to be greater than or equal to 0. Okay, very good. Now let's take a look at the next ones here. So this is problem 16 here, right? Okay, so I have a function. This is f of x equal to the negative x squared and minus x plus 6. So first things, I want to find the vertex. Okay, so at the same time, let's do it one more time to review here. So if I have a function f of x equal to is I have a quadratic x squared plus bx plus c, right? Then the vertex, the value of the x is equal to 2a minus b, all right? So now let's take a look at this ones here. So this is my quadratic. So this is -1, this is my a, this is -1, this is my b, and this is 6, this is my c, right? So the vertex here, the x value is equal to 2a minus b. 2a is -2, minus b, minus -1, right? So this is 1/2, -1/2. After you get that, in order to get the y value, what do? You just substitute, right? So it will be negative. So this is, you need to be careful, right? This is 1/2 to the square minus -1/2 plus 6 here. So the first one here is -1/2. So this is -1/4. Negative plus 1/2 plus 6, right? So you will get is 6.25. So the vertex here is -1/2. Okay, so -1/2 and 6.25. Okay, so now the axis of this matrix. Right? Axis of the symmetrics here. Let's do the review. The axis of the symmetric. Will just be x equal to the -b of 2a. So in here, for here, we know the axis of the symmetric, that will just be at the x value, the vertex. So it's -1/2. Okay, the next thing is here, x-intercept. So what is the x-intercept here? Let's try to review here. X-intercept is used when y equal to 0. Then you solve for x. Right? Okay, so now in here, let's try to do here. That means y equal to 0. So it's 0 equal to negative x squared minus x plus 6. So for the easy to factor, so let's take this negative sign out and make it a little bit easier. So this is minus 6. So this is negative x plus 3, x minus 2, right? So this one equal to 0, so x plus 3 equal to 0, so x equal to what? Negative 3, and the x minus 2 equal to 0, so x equal to 2. So the x-intercept is where? So I have a 2x intercept, right? It's negative 3, 0, and the 2 zeros here, okay? And the y-intercept, so D, this is a y-intercept. So the y-intercept, what is the y-intercept here? Let's do a review. Y-intercept is when x equal to 0, then you find the y value. Okay, so y-intercept is x equal to 0. So that's pretty easy. So y is equal to the negative 0 square minus 0 plus 6. So y-intercept is 6. So that's why we write the y-intercept is equal to the 0, 6. Okay, so the last thing is here, let's say graph, right? So in here, you graph here. Okay, then you have like, this is 1, 2, 3, 4, 5. 1, 2, 3. So 1, 2, 3, 4, 5, 6. Okay, so 1, 2, 3. Okay, so let's try to do the points here. Okay, so I know the vertex is negative 1/2, 6.25. So vertex is somewhere here. And because this is negative, so I know this one's here, this is going to open down, right? Because the first value A, the coefficient in front of x squared is negative, so I need to open down. Okay, so this is my vertex. Now, this is also the axis of the symmetrics here, right? So you kind of, if you want, you kind of, right? So this is the axis of the symmetrics here. Okay, so now x-intercept. X-intercept is negative 3, so it's here and here, and 2. Y-intercept is 6, so it's here, 0 and 6. So now you can graph it. So this will be your projected. Right? So that's what will be your projected here. It's pretty cool, huh? Okay, so those topic, your memory should still be fresh, right? Because we just finished the 4th exams here. Okay, let's take a look at number 17 here. Try to solve those exponential equations. So this is e to the 3x plus 2 equal to 1. Remember, when we solve it, we need to have the same base. So this is e. So this is e to the 3x plus 2. So what is the value will give you 1? E to the 0 powers, right? So we said e to the 0 power. So e and e is cancel. Now I can solve it. So that's why it's 3x plus 2 equal to 0. You minus 2 minus 2. So it's 3x equal to negative 2 divided by 3 divided by 3. So x equal to the negative 2/3. That will be the first answer. Okay, so now let's take a look at the second one. So this is e to x squared equal to e. This is 6x plus 7. Well, this one is pretty good because of what? The same base. I can cancel that out. Now I will just have x squared equal to the 6x plus 7, right? Now I move everything to the left-hand side. So it's minus 6x minus 7. So I will have x squared minus 6x minus 7 equal to 0. Now I factors here. So it's x minus 7, x plus 1 equal to 0. So x minus 7 equal to 0. I will get x equal to 7. Then x plus 1 equal to 0. I will have x equal to negative 1. So for this one, I will have two answers here, right? Okay, so now the next one's here. This is 125. And x plus 2 is equal to 25. 3x plus 1. Remember, we have to have the common base. So first things I need to change 25 and 125. What the exponents satisfy both? Wow, it's a 5, right? So 125 is 5 to the third. Then this is x plus 2. Then the 25 is 5 to the second. So this is 3x plus 1, right? So now, then you use the distributive property. All right, so now this one's here will be 5. This is 3x plus 6. This is equal to 5, 6x plus 2. Then now you will see, oh, good, they have the same base. Now I can cancel that, right? So now I can cancel it. So this will give you 3x plus 6 equal to the 6x plus 2. So minus 2 minus 2. So this is 4. So this is 3x plus 4 equal to the 6x minus 3x minus 3x. So this is 4 equal to the 3x divided by 3 divided by 3. So your x equal to 4/3. Right? Okay, it's pretty straightforward, pretty easy. Okay, next one, number 18. Okay, so we have the following rational functions here. So rational function means it's a ratio for the polynomial. So this is 2x squared minus x and x cubed squared plus 3x. Okay, so I want to find the asymptote and I want to find the holes here. So the first things here, before we do anything, let's try to simplify it a little bit. So this one's here, I take the 2 out. So this is 2x minus 1. I take the x out. So this one, I take the x out here. This one is here. This is x plus 3 is here. Okay, so now let's do a brief review. Okay, so vertical asymptote is the value at the denominator, value of x, which make the denominator equal to 0, right? Then the horizontal asymptote is when you limit. So the horizontal asymptote is when x go into the infinity or x go to the negative infinity, and the value of your y. Then the holes here is the value of x make the denominators equal to 0 before factor. So this is after factors here, okay? Okay, so let's see here, right? So in here, you said in here, I can do that. So similar, I can cancel this one out, okay? So now, what is my vertical asymptote? My vertical asymptote is after you factor out, what is the value, make the denominator. So basically you do like this, 2x minus 1, after you factor out, right? You look at this simplified fraction. Which one make a denominator equal to 0? Oh, x equal to -3. So this is your vertical asymptote. It's after the factoring, right? Okay, now the horizontal asymptote. Okay, so this is a 2x minus 1. This is x plus 3. So after you factor, so because right now they are running in the same speed, right? So this is the first degree, this is first degree. So because both in the first degree, so you just compare the ratio. So that's why the limit, so this one's here, when the limit x approach to infinity, so this functions here will approach to what? Will approach to 2, right? So that's why you say y equal to 2. This is your horizontal asymptotes. Okay, so what is the wholes here? The whole, this means before you factor. So before I factor, oh, the x's here will make it equal to 0, but after I factor, x disappears. So the wholes is at x equal to 0. All right, that's what we talk about is the asymptote, vertical asymptote, horizontal asymptote, and the wholes here. Okay, now next one's here. So number 19. I'm going to write the exponential to the log and the log to the exponential. Okay, so this is one. Let's try to review this. So we say the log and the exponential, they have the, so it's, this is a log x. Oh, no, sorry, here, let's do the b here. Okay, so this is log b, right? And this is the y to the x here. Now you can change that. This will be the b to the x equal to y, right? That's the formula we said we need to remember. That is how the log and the exponential changes here, right? Okay, now let's take a look at the first one. 3 to the -4 equal to 1/81. So you just need to compare and set each number to the correct value. So this is what? This is the b. Compared to that formula, right? So this is what? This is x, and this is what? This is the y. So now you can just flip back. So it will be the log base b. So it's log 3. Now y become inside 1/83. So it's -4. Right, so it's pretty straightforward. Okay, now the next one here, this is log 0.01 equal to -2. So remember here we said, if the log, you do not see a base under it, this is what we call this, the common log. So what is a common log? That means the base is equal to 10th here. So in general, we just don't write it, right? So this is, we'll call this the b, okay? So now let's do the same things here. Now this y here, this is y, and this things here is x. Okay, now use the formula, it's bx, so it's 10 to the -2 is equal to y, 0.01. So it's pretty easy, straightforward, right? Okay, let's take a look at part C here. Part C, this is e to the 2x is equal to y/3. So let's do the same thing to write down what we have. So this is my b. The whole things here, this is my big X. This is my y's, my green y's here, right? So now let's try to change that. So it's log base is e, so it's log e. Y, this is y over 3 equal to x. My green x is 2x. And also, we can see one more step, log e. So what is log e? We say log e, we can write it the natural log. So it's natural log of y3 equal to the 2x. Okay. Now let's see the number part D's here. This is the natural log e is equal to 1. How do I change it to the exponential? Then you say the natural log, really, like we talk about, is a log with base e equal to 1, right? So if you can think about the natural log is the log with base e, now in here, now you can say here, this is my b. What is this one here? This is my y. What is this one here? This is my x. So now you can rewrite it to the bx. So it's e to the 1 equal to e. Okay, that's pretty easy, right? Okay, now let's go to the next province here. Okay, number 20. Part A, we said this is a 9 to the x minus 1 equal to 4x. Well, you see that we say, hey, when we try to solve the exponential, we hope we have the same base. Then we can cross the base out. But now in here, we have a different base. So the way we do that, we can take log both sides, right? So we can say, okay, let's try to simplify it. Take log both sides. So typical, you can take any type of log, but I prefer take the natural log. So you will have a natural log 9x minus 1 is equal to the natural log of 4 to the x. And then by the exponential rule, I know the log, if you have exponents, what you can do, you can move these exponents out. So this is x minus 1, then this is natural log 9, then this is x natural log of 4, right? Okay, so now you can use the distributive rule to separate the x here. So this is x natural log 9 minus natural log 9 is equal to the x natural log 4. Okay, it's just like we solve I add natural log 9 both sides and move the old number to one side. So this is, I have natural log 9 is equal to x the natural log 4 plus natural log 9. Now I need to move the x to one side, so I minus x natural log 4 minus x natural log 4. Okay, so here, this one's here, it will just be natural log 9 minus natural log 4 to the x's, right? So then here, this one and this one, they cancel, right? So here, this will be equal to the natural log 9 here. Then you divide it, just like we solve in the algebra. So natural log 9 minus natural log 4. This is natural log 9 minus natural log 4. So I will have x is equal to the natural log 9. And this is natural log 9 minus natural log 4. If you want to simplify a little bit, so you can do it. Natural log 9 minus 4 is just 9 over 4, right? So that's what will be your final answer. Okay, let's take a look at part B here. The part B, this is 5x, 3, the x plus 1 equal to e. Oh boy. So for these ones here, we can do the same thing. I can say I will take the LE both sides. Okay, so in here, this will be 3, the x plus 1, 5x equal to the natural log e. Correct? Okay, so I know the natural log divide is equal to natural log minus. So this is 3 to x plus 1 minus the natural log of 5 to the x. And what is natural log e here? See here, natural log e. This one really is log to the base e to the e, right? So in the property, we say this is equal to 1. So this is equal to 1. Okay, now I can use the exponent property, move this one and move this one to the front. So I will say this is x plus 1. This is natural log 3 minus x natural log 5 equal to 1. Okay, then distributive property, right? So I will have x natural log 3 plus natural log 3 minus x natural log 5 equal to 1. Okay, I can minus natural log 3 minus natural log 3, move that to the right-hand side. So this is natural log 3 minus x natural log 5. This is 1 minus natural log 3. Now you can factor the x out. So this is natural log 3 minus natural log 5 equal to the 1 minus natural log 3. Then you divide by the natural log 3 minus natural log 5. Divided by this is natural log 3 minus natural log 5. So what is your x value? The x value is 1 minus natural log 3 and the natural log 3 minus natural log 5. Like I say, if you want to combine a little bit more, you can do that. So the natural log minus is divided. You can do this. Okay, so that's how do you solve the x with the exponential. If the base is different, then you cannot just cancel the base. You can try to find the same base. If that is not possible, like 9 and 4, I don't see any number, will be the common base for them. So what you can do, you can take the log function both sides. Then use the log properties. Now we have 3 very important log properties. If your log add log will be log multiply. Log minus log will be log divide, right? Then if you have the exponents inside the log, you can take that out. It's like your multiplication of that log. And that's it. And I'm so glad we be able to finish this semester. And I hope that every one of you can finish this semester strong. Okay, make sure study for your final, and I'm looking forward to see you maybe next semester. We will bump to each other, in the campus here. Okay, good luck on your final. If you have any question, do not hesitate to send me an email. Okay, talk to you later. Bye.